have angle between them. If I'm to get the resultant of the forces, I can get it from the root of the square of the first force plus the square of the second force, and then plus 2 times the first force, the second force, and the cos of the angle between them. That one gives us the resultant of the forces. Okay, so that is what we're calling the parallelogram law, that you can easily master it, relating it to something in our pure mathematics there, what we are calling the cosine rule. Only that for cosine you'll be having there a minus, but basically it tells us that even someone can use cosine rule to solve this kind of problem. So this is our parallelogram law. So now let's meet for the second part, and that is going to look at the direction of the resultant. How then do we get the direction of the resultant of the forces? That is what we are going to look at, because we have said that every force, isn't it? A force is a vector quantity. It has both magnitude and direction. How then do we come up with the magnitude and then the direction? The magnitude we have seen from the parallelogram law, and then let's look at the direction. How do we get the direction of the forces? So note this one as our parallelogram law. You can put it something like that. That is parallelogram law. Then let's look at the direction of the resultant. Because we are not just going to look at the resultant and then we stop there. We should also go deep and then dig into the direction. So direction of the resultant force. So if we are to get the direction, and on our drawing here, we're saying the direction is the alpha. Is that the direction can be given by the angle. So if you calculate the angle, you're basically trying to look at the direction of the resultant force. So how do we get the direction? We can now say from triangle DAE, what is that triangle? I can maybe sketch it here so that we can DAE. Our resultant is here, and then the alpha, that is the direction, is there, and then I have this side as the F1 sine of theta, and then I have this side as the F2 plus the F1 sine of theta. So can't I get alpha from there, because alpha is the direction? So I can now say from that triangle, my tan of alpha equaling to opposite F1 sine theta divided by F2 plus F1 sine of theta. And then now you can go ahead and now maybe tell us that alpha is equaling to the tan arc of all this expression here. And then divided by F2 plus F1 sine of theta. And always when we are mentioning about the direction in terms of angles, angles should be measured from respective axis. Can be horizontal or vertical, isn't it? We don't just measure the angle from any other direction other than that. It should be with respect, at least from the horizontal or from the vertical, one of them. So now for us here, our alpha that we are talking about is with respect to the horizontal force F2. So you say the resultant is the value you got here, and then you get this angle here, but you say the angle alpha, I measured it beginning from the what? Beginning from the horizontal force F2. We should measure from the horizontal. So don't measure from a point like this and then you start concluding like this. This is not horizontal, not even what. So you will be very wrong for yourself. So angles will be measured with respect to some known axis. So this is one way that you can deal with our direction. Or if that has been so hard for you, you can also look at another triangle. If this one has been hard, then let's look at if this will also be now simple instead. You can also instead look at it from our triangle DAC. Our triangle DAC. What is triangle DAC? That triangle is just this here. Let me see if the sketch will come out as related. This angle here is theta because we are saying A, C is here, and then D is here, and then this is F1, and then this is my alpha, and then this is my F2, and then this is my R. And our interest is now in this will now be 180 minus theta. Angles on a straight line. So this will be 180 minus theta. Minus theta will be that angle there. So how do we now get alpha from there as our resultant? And then the variable of this here, we can say from here now we can go back and pick our idea of pure mass, and then say we can now say using sine what? Using here sine rule, using the sine rule, which use sine rule, not the extended one. So we shall say that F1 out of the sine of the angle that is opposite rho, and then we shall say also we can now look at maybe R out of sine of R, also we can say sine of what? Sine of 180 degrees minus theta. And then you can extend it to this one here, F2. Supposing you call this angle here something like beta. Okay? That is assuming it is given. You choose what is very relevant to you, or if they are known, you can pick any pair and equate. So you can now say F2 over sine over beta. Okay? So now from here, but make sure that at least the alpha we are looking at is there in the expression. You can pick it with this or with it, depending on what has been given to you here. So you can say F1 out of sine alpha is equaling to R out of sine of 180 degrees minus theta. If I'm to equate that, and I'll say my sine alpha is equaling to my sine alpha cross multiply and say F1 sine of 180 degrees minus theta out of the R. And your alpha can be the sine inverse or sine arc of F1 sine of 180 minus theta out of R. So this can also be your second method of you can use this triangle or this, whichever that is very relevant to you, and then you get the direction of the resultant force, and that is something to do with the parallelogram law. So having looked at how we get the direction, and then let's look at some guidelines in drawing the parallelogram, because we said that the whole knowledge of handling parallelogram law is all about dealing with the parallelogram. So how do we deal with the parallelogram? Is it just a matter of drawing it? So note that if if the angle between the two forces is acute, that is to say 0 less theta less 90 degree, comma, then the parallelogram takes a shape shown below. This one will guide you so much when you are drawing your parallelogram, that if you have the angle between the two forces, you've been given the force and the angle is between 0 and 90, the 60, you should draw your parallelogram in this format here. And then the resultant will be here. This will be your F2, this will be your F1, and this is the theta we are talking about if it is acute. So draw your parallelogram looking like that. And then 2, if the angle between the two forces is obtuse, that is to say 90 less theta less 180, we can say the parallelogram is of the shape shown. So now if the angle is beyond 90 but less than 180, our parallelogram is now, you should draw like that, means that the forces are like this now, isn't it? That means F1 would be here and F2 would be here, and here is now your theta. Whereas for this one would be angles less than 90 would be like that, F1, F2. That means that parallelograms should be completed like this, and then like this, and then the resultant always in between will be something like that as the resultant. So be very, very careful when you are looking at some cases that will require you to first draw the parallelogram and then resolve the forces. So let's now meet in the next example.